Okay, so good evening, everyone. Uh, am I audible and the screen is visible? Can anyone confirm via chat or opening his mic or her mic? Am I audible? Yes, okay. So, let's wait for 2-3 more minutes. Uh, Actually, I'm not in India today, so I'm having some bandwidth issues, and the timing is also 15 minutes plus according to Indian Standard Time. So, as per my meet time, it is 6:15 p.m. That is India's 6 p.m. So, according to my time zone, I will finish the lecture by 7:15, and I am having some bandwidth issues, so I am pausing my video so that I can use my limited data. So, let's wait for 2-3 more minutes. Let others join, then we will get started. So, in this week, actually, the main focus was on the indexing and hashing techniques, what was taught by Korth sir, and also there were some live sessions. You can join. Those live sessions are from faculty side, so those are actually very informative. So, uh, in indexing and hashing, the main motto was to sequentially organize. Uh, yes, someone raised hand. Is there any problem? Okay, so if there is any issue, please just inform me because I am having very limited internet today and bandwidth is not good. So if you are not able to listen to me, or if there is any kind of issues with the PPT, it is not changing, then please tell me uh, as you get any problem.
You are clear, audible, sir.
Okay, okay. So in indexing and hashing, the topics those were covered were actually the ordered, then in ordered, then and there are some hashing techniques, and there were trees
I
to arrange.
I have a request that if you can explain with examples like the difference between sparse indexing and dense indexing and all that, because it was not much clear to me in the lectures actually.
Okay, I will try if I have created examples for all of them. You just do one thing. There is discussion forum. You just write there. I will definitely cover those things you are telling in next lecture. Uh, just do one thing. If there is any topic you are not getting from lectures, just post it on discussion forum. I will cover it next week because before lectures I have to make PPT for everything, so I cover accordingly. So
I mean, is it not possible that if you yeah like electronic pen through? I mean, if you can explain that.
means immediately we cannot means take an example. So that will be means I create lectures according to 1 hour, total 1 hour time. So I have to cover all the things which were covered in last
Actually,
year's assignments.
in other live sessions, other TVs like there is a possibility that they can explain by by pen. I mean, electronic pen
If
through.
if you will write on discussion forum, I will definitely cover it, cover your topics which you are not getting in just upcoming lecture, my lecture.
Okay, okay.
Okay.
How many lectures? I mean, more live sessions we have this
Uh,
week.
from my side, there are two left, and I think next topics are mostly in literature. So if you will means write over there, I will definitely cover. I will
Okay.
take some time from NPTEL and myself. I will definitely cover accordingly.
Okay. Thank you.
Okay. Yeah. So let's get started with the previous year questions, and if you will get time, so then I will try to get some more. Yeah. So is my screen visible? There is question one and question two.
Yes, it's visible.
Okay, okay. Thank you. So this is actually for previous year questions. This is for choosing correct statement or incorrect statement from the options. So first is telling that a database file can have multiple cluster indexes. So cluster index means the primary index. If you will go through the PPTs lectures, there was written that cluster index is actually the primary index in means we write it as cluster index. So uh, first is the wrong statement. Coming to the next, it is telling that a database can have only one clustered index with multiple secondary index. Yes, there is only one primary index, then there are multiple secondary indexes, as we have some uh, index tables, then there are connected tables for which have secondary indexes. So second is correct. Let's see the third one. A database can have multiple primary indexes. That is also wrong. A database file can have both primary index and the cluster index. So both are same. So it will also be wrong. So answer is B option. Coming to next one. Choose the incorrect statement from the following options. Okay, these are some theoretical questions. If you have,
So
yeah,
I mean, I need to know how the option D is wrong, because when I mean,
I have both. Is it writing both? Primary index is actually called as clustered index. If you go through PPTs, there is written, there is a point. So we will have only one primary index. So this is not, they should not use both here. Then in second one, we have to just check for the wrong statement. So sequential scan using a primary index is inefficient. That is wrong. If you go through the lectures, there is a clear point that if we are going for sequential scan, we can rely on primary index itself. So that is the wrong statement. One. Then sequential scan using a secondary index is expensive. No, it is the correct one. So it will not be the answer. Secondary indices must be the dense index. Yes, secondary index. Then those index are for primary index can be sparse one. Then in multi-level indexing, a sparse index of a primary index will be created in a inner index, not in a inner. That will be the outer index. So answer is A and D both. Okay. Now uh, coming to this question. So uh, we are not responsible for NPTEL exam, so we can't comment on the pattern. Uh, you can this kind of doubt you can just post on discussion forum. There is a discussion forum option in your course menu. Ask a question kind of menu is there. So from there you just write your questions which you want to ask, the topics you want to cover again. That we both TAs Anand and me will try to cover those topics, and also this kind of problems like for exam or any kind of NPTEL based query, you can just post on discussion forum. I will definitely they will means uh, there are departments, so NPTEL will comment on their one. We will be responsible for your queries regarding to any doubt or any kind of lecture, and also if there is some problem with assignments or questions, you can post there. The team will definitely inform you. The means the right guys will answer you the right answer. Okay, the right guys will inform you. Okay, so these are the questions. You all have I think gone through the lectures. So if there is any problem with the concept I am which I am not able to cover today, I will not be able to cover today, you just write on discussion forum. I will cover it in next week. That there is no to means answers, and if you know the answer, uh, will have numerical with MCQs same as assignments. uh, no, it's means previous year assignments, not same year. uh, we are told to cover the previous year assignments and the some if there are not visible question, not feasible question for any topic, then we can take it from other sources. So our basic work is for me and Anand, both PMRF TAs, are to solve these questions for you once, means tell you how to solve these questions, or if there are any means discussion related doubts which are there in discussion forum. Okay, so if you know the answer, you are able to solve the questions, just comment the answers here. So a database file is indexed by hashing with bucket size 100. Hash function is key by 11, then modulo 100. Compute the location where this key will be placed. Okay, so for this key, just apply this hash function. Hash of key is given key by 11 modulo 100. So now key is equal to 17193 by 11 modulo 100. So if you solve it, it will come around 1563. Okay, just solve it modulo 100. So if you take modulo 100, what will you get? We'll get 63. So the location will be at 63. Answer will be C. Okay, very simple one. Very simple one. So next questions are about 234 trees. So the basic concept which was taught in the lectures for B plus tree and for this indices kind of thing was 234 trees. So uh, I will cover some questions based upon this. So there are three kind of nodes which satisfies key relations. The two node must be a single data item, then three node having two items, four node contain three item and four rings. Then leaf may contain one, two, or three data items. So next question is very similar to this. We have to just select the correct one. So uh, just if you see if we have one node, we have two node, then the left one will be less than s and right one will be greater than s. If we are inserting some link in between, then it will be in between s and l, and the last will be greater than l value. So coming to the options, if you see here, we have sml, that is the 4 node. It is having less than s, then this is between s and m, between m and l, and greater than l. So this is correct one. then it is in B option it is writing as greater than S, so it will be the wrong one. Then the third one, there is greater than S, less than L, then greater than L, so it is right one. So A and C till now are correct. The last one is here one condition is missing, it should be less in between L also, S and L, so that is also wrong one. So answer will be A and C. Okay, so fifth answer is A and C. Now there is 2 3 4 tree, it is like AMT. What we have to do, we have to insert this uh, these much nodes, these much values in this given order. Okay, so we will do one by one. Just here we will apply all the concept regarding which are used in this 2 3 4 trees. So first there is AMT, we have to apply C, we have to insert C here. Okay, now there is a concept of node splitting. If you remember, if there are more than three elements in this node, then it will be splitted if anyone is getting inserted here. So middle one will be the root, then less than this M means middle one will be on left leaf node, and right will cover the greater one. Okay, now if we will insert C, these two are actually equivalent. Okay, now if we will insert C,
Hello.
yes, please.
Sir, you are explaining B plus tree.
No, it is 2 3 4 tree. B plus tree is
Okay.
extended version of itself. Yeah.
Okay.
Now, if you will look at the sequence, it is actually in alphabetical order. So the alphabet having uh, means we have to go by alphabetical order. If any alphabet is having lesser value, means it comes before before the root word, it will come on the left side, otherwise right side, and accordingly for 2 3 4 ways. Then so if you will insert C, where it will be inserted, you can just see here. Okay, because it is less than M, and uh, so now this node is it was two node, now it is three node. Okay, this is three node, AC is three node. Now we have to insert H here. So if we want to insert, where it will be inserted, it is also less than M, it comes before M, so it will also occupy the leftmost leaf. So what we will get, A, C, then H. Right side is having T only. Okay. Coming to the next one, what we have to append, we have to insert J. Now for J, what place it will take? If we see here, uh, J comes before M, so it will occupy the left leaf. Okay, but it is already 4 node, so it will first get splitted and make the uh, it will make its equivalent one, it will be decomposed in its equivalent one. So actually what it will become, it will become something like ACH will become A, H, and C will become at the top root node. And is there any root node exists, so it will be appended with this uh, 2 node that is on root. So C will be uh, C will go with M. Now it is 3 node, and the next two nodes A and H will become two leaves, and this will be T. Okay, now we have to insert J in this. Now we have to just select the right position for this J. So J is actually, J comes before M and after C. Okay, so uh, this will occupy this leaf node. So there is C, M, there is A, there is T, there is HJ. Okay, J comes after H, so H. Now we are here now. Now we will go to B, where we can insert it. It is very simple. B comes before C, so it will occupy this left node. So the tree will be C, M, A, B, H, J, then there is T. Okay, now we are here. We have to go to I. We have to insert I. Okay, so where will I go? I will come at this. I comes before this M and after C, so it will come at this place only. Okay, C, M, oh, now there will be A and B, there is H, I, J, and there is T. Okay, now we have to insert R. Where it will take place? It comes after M, so to the right leaf, C, M, A, B, H, I, J, then R, T. Okay, this is done. Now the last one, K. Where will K go? K will be going in this node, because it comes before M and after C. So but it is already 4 node, so we cannot append directly. Means we cannot insert K directly. What we have to do, we have to first uh, decompose it, split it. On splitting, what we get, so it is Hij. So I will be going to the, I will occupy the root node. I will become the root node, then Hi, then J will be on right side. So these two are actually, this one and this one are actually equivalent. Now we had to take all leaf nodes in a in the same level. So what we will do, we will take this I to the root node. Now when we will take it to the root node, it will become 4 nodes. Earlier till now it is 3 nodes. It will become 4 node after that. C, M, I. Sorry. Uh, I comes,
Okay, I got key.
yeah, C, then I, then M. Now, this node will be there, left side of C. Then there is a node H which comes before I and after C. There will be the node J which comes after I and before M, and there is RT. So we have to insert I. We have inserted it. We had to insert K. K. Thanks for reminding. We have to insert K. So where it will go? It will go just. Please join at time. Okay. So K is there, and it will come just. It comes after I and before M. So it will be there with J. So J K. Okay. So if I mark it, okay. So first I inserted C. It came here. Then after C, it was 2 node, and H comes just before M. So we can append H here. Then if we want to attach J, so what will happen? We have to just check where it will go. So what happens is that it was actually 4 node. So 4 node, we cannot insert any element in that. So we just created an equivalent one, which was ACH. Okay. So whenever we split the node, the middle one gets the root node. Middle one becomes the root node, and left the first element becomes a leaf node, and the next one becomes a right leaf node. Now what we have done, we just created an equivalent of this. So we had the root node here, C, which has value only M, and that was the 2 node. So we converted it to 3 node using getting 3 here, and then we just applied J here, and J is actually J comes before M and after C, so it is here. Now we had to append B. So B was very simple. We have to first check where it can be placed. So it can get placed before C. So we inserted it here. Then I comes before M and after C. So I. Now we had to append R. So R is there. R comes after M. So we inserted R here. Then at in the last step we had to insert K. So what it will do, we had to check the tree. We have already Hij here, and K comes before M and after C. So we again splitted it in this way, and I came into the leaf node, root node. Okay. Now we have H, J, and K. So it is our last 2, 3, 4 tree. Sorry, just a second. Okay, so Got it? So this is how we create this 234 tree. So wherever we have to use it, the B plus tree are just extended version of this. So some more features. Okay. Next two questions are very simple. Just go through these properties of B plus tree. So a B plus tree is rooted tree satisfying the following properties. What are the properties? All paths from root to leaf are of the same length, which was actually in your 234 tree also. Then each node that is not a root or a leaf has between n by 2 and n children. Okay. Then a leaf node has between n minus 1 by 2 ceiling function and n minus 1 values. Then the special case is if root is not a leaf, it has at least two children. If root is a leaf, there is no nodes in a tree. It can have between 0 to n minus 1 values. Okay, so coming to this question, what we have to select the correct option. A leaf node has between n by 2 to n minus 1 by 2 keys. Okay, so so it is wrong. Then leaf node has between n minus 2 by 1 minus 1 and n keys. Wrong. You can see from here it should be n minus 1 by 2 and n minus 1. So C is right. There is no floor function. It is wrong. So it is simplest as per literature question. Okay. Next, the order of an internal node in a B plus tree index is the maximum number of children it can have. Suppose the children pointer takes 8 bytes. Okay, so pointer takes 8 bytes space. The search key field value takes 10 bytes. Then the block size is 512 bytes. Okay, so block size is having 512 bytes in size. So how many bytes we want to store the values in blocks? That will be actually 2 to the power n. So n is equal to m. We can say m will be equal to um, it is 2 to the power, I think, 11. Yeah, 11. So m is 11. So total data we are storing, it takes 11 bytes. So identify the order of internal node. So that will be the total of these three. 8 plus 10 plus 11, that will be 29. So answer A is the correct one. Okay, so we have to just check how many bits we can store, bytes we have to take to store it. Coming to the next one, it is looking very large, but it is very simple one. So we have to consider this relation, and we are given bitmaps for this age section. Okay, with A1, A2, A3, A4 representing the maps for age intervals. Okay, so we have to check the bitmaps, and if it will match, we have to say it's right, but we have to point out the incorrect statements. So let's check it. So first is A1. So wherever it is 1, we have to select that value from age. Where it is 0, we have to drop it. Okay. So 1, A1 has 1 for 25. 1 is done. Next is 18. Okay, I can write it like this. That will be, I think, better option. If we write A1 here. 1, 1, 1, 0, 1, 0, 1, 1, 1, 1, 0. So it is telling that A1 is bitmap index for age below 40. Okay, let's look at what A1 is selecting. Age below 40. Okay, this is the first one. 25 is below 40, 18 is below 40, then 47, sorry, okay. So A1 is below 40, A2 is, sorry, H1 is below 40, then this is greater than 20, it is 0, but it is 42. So it is not below 40. We have this, this is incorrect because it is not satisfying this condition. Now, coming to the next one. Let's go to A2. Okay, 0, 0, 1, 0, 1, 0, 0, 0, 0, 1. So the claim is that bitmap index for age 40 to below 60. Age 40 to below 60. So first it is targeting 47, then 53, then 55. Okay, there are only 3 maps, but it is not taking this 42. So that's why it is also wrong. Okay, coming to the next one. A3. So 1, 0. Oh, just a second. I'm rejoining. Is my screen visible now?
No, sir. It is not visible.
Okay. Okay. Yeah. Now visible?
Yes, yes, visible.
Okay, thank you. So again, I was doing for A3. 1 1 0 0 1 1 0 0. Now the claim is for age 25 to below 50. Age 25 to below 50. Okay. So for okay, just 25 here, 57, 52, 37, 30. So all are, I think, 25 to 50. And is any index is remaining? I don't think so. It is the right one. Then again coming for A4. Again disconnected. Just a second. Just a second. I'm rejoining. Just a second. There is network issue. Just a second. Okay. 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 Is it visible again?
Yes, sir.
Okay. Thank you. Okay. So I was doing for A4. Please, please close your mic. Okay. Fine. So 0 0 1 1 1 0 1 1 0 1. Okay. So what we have to check? We have to check for age 30 and above. So this one, this one, this one. Okay. So if we see, we can see that this is actually 30 above, and if there is any left, nothing is left. So C and D are the correct ones. Okay. Now, is there is anything left? This not happening. This. Okay. So for today, the questions are done. I'm trying to open this PPT, NPTEL PPT, and try to tell about this sparse and dense index, what you have told earlier. So let's uh, discuss these things again. So in these questions, if there is any doubt, so I can proceed with the NPTEL PPT. I don't think these are very simple questions which were asked in the last year assignments. So okay, I am opening the NPTEL PPT. We will go by there. So I will not be able to write on that because that is not in my writing system. Just give me 5 minutes. Okay, so indexing. So indexing is used for searching the records. So in index file we will have two things. This we all know. Then there are ordered indices. There are hash indices. Where in ordered indices we have search keys are stored in sorted order. So according to that order we just search. Then there is hash index in which there are buckets that are distributed, means search keys are distributed uniformly across the buckets. Then there is evaluation matrix. Then this is ordered indices. So ordered indices are actually there's the previous one which was taught, that in naive way you can just think it like you are having some book, you have index for that. There is a key where, like, there is a computer book, there are multiple chapters from chapter 1 to n. So that it is very similar to this. Okay, so we have this ordered indices. I can try to write network. Okay, oh no, it's very bad. Okay, just I'm trying to go with this cursor. So this is one thing. Then in that sequential order file, what I have earlier told, it is also called the clustering index. So sequentially ordered file index whose search key specifies the sequential order. So the main key is means the main index is actually the primary index. Then there is, if means there is some different order than sequential order. So for that we can use secondary key, but the essential thing is the primary key, that is also called the cluster key. Now, like in dense index, what happens that there is each of the record, and with the record there is a specific search key. So like here you can see each of the record is pointed by a single search key. That's why it is dense. Okay, we have a key for each of the records. Next we have this there may be different options, like we can means point to the different kind of oh, please join on time. Okay, so next type of key is means we have to take just one attribute and we have to point it. Okay, so for pointing is here we are pointing to the this serial number or the candidate ID, I think. Then there is if we point according to the subject or department name, then we can uh, point department wise. So biology, for biology it will go to biology. Then there is computer science, so computer science are pointing. Then the next is electrical engineering, and this way each of the means the cluster will be created, means that is kind of cluster. We are creating cluster based upon this uh, subject here. Okay, then there is sparse index. Sparse index means only there are some search key values. Now here what we want to do, we want to create uh, we want to have some values which are not actually whole key values. uh, if I say in other words, what I can say is that let's consider um, from this example itself. Just see whoever told me to give the example. Just consider this example. Here I am just taking some of the values those are uh, present in this means serial number or what, ID. Okay, so these are IDs, and in dense case we were pointing each of the ID, but if we are considering the sparse one, we are pointing some of the IDs, not each of the IDs. Okay, uh, so Jamboard you can use. Actually my device which I am using now, it's don't have this means writing pen kind of thing. If I try, I will not be able to. It is very distant from cursor. Okay, I'm trying to find this. Okay, 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 it's getting okay. So if we see here, okay, in case of dense index, what was happening, we were actually pointing each of the IDs. Okay, there are IDs, there are IDs for instructor. There is not only one, we for each of the record we have different pointer here. Okay, now coming to the sparse one, what sparse index is doing, it is taking some of the IDs, and based on those IDs it is trying to cover the IDs in between two IDs. Okay, so we are not actually considering all such values, we are actually considering some set of such value, subset of that such value, which through which we can explore, we can go to each of the record. Okay, so if we want, okay, I request everyone to please join on time. I every time I have to just change my windows whenever I just accept. Just take 15 first 15 minutes, join there, and otherwise means I have to accept all the incoming request, but for each time my flow gets affected now. So okay, now what we have to do, huh, so again I am starting. in case of dense index, we have to point each of the value that is there for the attribute. But in case of this sparse index, what will happen, we will take some values with the help of which we can cover each of the value. Okay, so for example, just consider this these two. If I am using 10101 and 32343, so from 101 to 324 uh, 32343, and afterwards we can just apply the condition like if there is some entry we want to insert, or we want to just read from the database, if it is in between these two values, it will be we will just search in means this what we can, I can say, in this set of database, not overall database we have to explore. Okay, so if we have two indices uh, or and then just consider if I have some record like I have given uh, 27000, and that is some record here, or just consider this 22222. Okay, it is in the record, but if we go through this dense index, we have key for this. Okay, we will go through this, but if we have have sparse index, what we will do, we have 10101. From here what we will do, we will just take this these two numbers, and we will just go in between them, because 22222 is actually in between, lies in between 10101 and 32343. Okay, so we will just traverse in between these two records. Okay, in this way, what the advantage we are getting, we can actually explore overall database based on some specific values, not we don't have to go through all overall database for that. Okay, means just here are some 1 2 3 4 5 6 7 8 9 10, total 12 entries are there, but consider for lack of entries, then what we will do. Okay, so for that, if we have 1 lakh records having 1 lakh IDs, okay, so what we will do, we will just create index, sparse index for consider 10,000 intervals. Okay, so 0 to 10,000, then next will be 10,001, then 20,001. So if there comes any record like 15,000, then we will traverse in between the indices. uh, those are values from 10,000 to 20,000. Okay, getting it? I tried my best. Okay, so in this way we can go for the differentiate between dense and sparse indices. Next from next week, you just if you have any doubt regarding this, you just write on discussion forum. I will definitely take some other example, those are not in this lecture, or if you want any other kind of discussion related to some specific topic that are covered in till the week or before it, just post there. I will definitely cover it. Okay, because before lecture we have to compile, so that you cannot get any kind of wrong information from our side. Okay, we have to prepare lectures according to 1 hour duration. Okay, so okay, that's all from my side today. If there is any doubt, any kind of queries, just post it on discussion forum. I will definitely cover it in next week lecture. And if you want to me to discuss any kind of doubt regarding to any topic or any specific example you are not getting in that means lecture, you just write on discussion forum. I will definitely discuss, either me or Anant, we both are for that only. Okay, so thanks a lot. I am ending this call. So we will meet next week. Okay. Thank you, everyone.